Welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, December 20th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights, the North Pacific Ocean, we see remnants of a gale pushing into British Columbia with seas still in the 16, 17 foot range, but they were higher earlier. And of more interest, a broad, complex gale trying to develop in the far west, northwest Pacific with seas in the 34 foot range and forecast to build a little over the coming days. Swell is in the water and more swell is on the way. Let's get into the details. As usual, we start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, a dip in the jet, just like what we have there. And the dip isn't very large, but look at the wind speeds underneath or at the apex of the dip. That is 210 knot winds. That's a very strong, very consolidated jet stream flow, and that is exactly what we want to see, because the more wind energy you have in the jet, the more it consolidates, the better its propensity to form troughs. And what happens in a trough? Well, that helps form a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And low pressure, we know, generates winds. Winds, if they're strong enough, generate seas. Seas, if as they radiate away from the fetch area, turn into swell. And swell, when it hits your beach, turns into surf. So we have a broad developing trough being fed with just great fundamentals. 210 knot winds pushing off Japan. That should set up development of low pressure in a gale here. Now the jet, you notice it kind of splits as it gets to a point. Hawaii's right there. You can barely see it. Right about there, there's a brick wall. The jet splits. Notice much weaker energy there. No real troughs indicated. The northern jet is pushing into over British Columbia, and the southern jet just like weakly limping into Baja. No real support for gale development there. All right, let's put this into motion. As we move into time, into Monday, the trough continues building, pushing over the north dateline region, we'll call it that area. There's the dateline, 180 north. We want to be south of the Aleutian Islands. Once you get up here into the Bering Sea, no swell generation possible. The islands completely block whatever fetch and seas are developed there. Anyway, as we get into Tuesday, you see the trough continuing into we'll call it the northwestern Gulf of Alaska into Wednesday. Winds start dying, but the jet is completely consolidated. Notice the split point moves from a point north of Hawaii to 140 west right here. That's not too far off the California coast. And then continuing into Thursday, still the trough in play in some fashion. And if anything, winds start building off Japan. Thursday night, as we get into Christmas, we have a newly developing, we'll call it reinvigorated trough with a fully consolidated jet pushing, look at the split point here, right there and there, moving onshore over California on Christmas. So trough here, possibly another trough developing in the northwest Pacific beyond as we get into Saturday. Sure enough, there we go. Winds building to, 170 knots off Japan. Pretty good looking pattern, actually. You notice a little bit of excitement here. So this is good. And then we just go on into Sunday. Here we are 180 hours out. Trough pushing inland, probably producing rain and snow for California. Another trough building over the North Dateline region. Pretty good active pattern in play, suggesting that storms, surf, and weather are all possible. Let's go take a look down at the surface. Here we are, surface level pressure, surface level winds, and as expected, a broad gale is developing with being supported by that great jet stream flow, filling the northwestern Pacific with winds 30, 35, 40, 45 knots in this sort of fragmented area here. All this fetch, this is the cold front, south winds ahead of it, all aimed up at the Bering Sea and of no interest. As we get into Sunday night, the gale continues. It just sort of plows its way across. As we get into Monday, notice the expansion of the fetch area. 30 knot winds continuous over a very large area. That Continues into Monday night. Then we get into Tuesday. The gale sort of stretching out, not particularly well organized. Notice a new little fetch forecast trying to develop as we get into Tuesday night and Wednesday. Not sure if that's going to materialize, and it doesn't. And the whole thing sort of starts falling apart. There we go. The fetch finally, that little mini secondary fetch starts developing Wednesday night into Thursday, lifting mainly north. Not of particular interest, but one. Here's another low starting to develop as we get into Thursday night. And notice there's something going on over here as we get into Friday. So 1, 2 new gales. I mean, you kind of get the picture here. Just a lot going on. 55 knot winds. This is actually a storm as we get into Friday night and Saturday over the dateline. And then another one building behind that. This looks like Christmas presents en route. Oh, wow, look at this. Filling the entire North Pacific as we get into Sunday. I don't know if I'm going to believe the models. That seems a little bit too hyped up, but a lot of weather. One system off of California, a huge one filling the North Pacific, another one developing off Japan a week out. So it looks like at least we're in a favorable pattern now. Hard to believe. All right, so now we're going to look at the effect of those winds on the ocean surface. We're going back in time a little bit to Wednesday of last week. Gales started developing over the North Dateline region, 20-foot seas. I mean, this is not an impressive system at all. We'll say 21-foot seas, and it pushed up into the northern Gulf of Alaska as we got into Friday. Swell from that system it started hitting California on Saturday. Another one was behind that. We'll just do a quick look. It started right about Friday. It has produced yet more swell. So swell is hitting Northern California right now. I mean, waves are in the couple feet overhead range, offshore winds, pretty good setup. And that's all from these kind of I generally call generic, not great looking systems, and it's making surf. So that gets us into Sunday. Now let's go take a look at the forecast. Yeah, so here we go. Looking at the forecast now. So that explains those nebulous generic systems are what is generating the surf that's hitting the U.S. West Coast and Hawaii right now. Sideband energy into Hawaii. Nothing huge there. We have the new broad system, but the issue with it is the fetch wasn't really consolidated. It wasn't that strong, so you get this kind of fractured pattern of 28, 30-foot seas sort of thing. Still, covering a broad area. Swell will result in this for both Hawaii and the U.S. West Coast. You can literally see the seafront right here of energy pushing towards targets to the east. We're into Tuesday now, still 20, 22, 24, 26-foot seas. So we get into Wednesday, and the whole thing sort of falls apart. We saw this one little fetch that developed up north, get 28-foot seas out of that. But we're not even looking at that. The real interesting stuff starts on Christmas Day. First, the system in the Gulf with 24-foot seas. Actually says 26-foot there, but yep, that's right. Building to, there's your 26-foot seas, and up to 32-foot. 2 more behind it. You can sort of watch. This one plowing right towards California. Another one behind it, 32-foot seas. A broader one with 32 or 33-foot seas behind that. And we're 180 hours out. Now, nothing with giant seas. No 40-foot seas, no 50-foot seas, though this one here, yesterday's model, had seas up to 53 foot. So the models are very unstable, very unsure exactly on how all this is going to play out. So we're not tied into any particular outcome here. But the general pattern is it looks like a good jet is going to be supportive of a storm pattern, which is going to be supportive of sea development, which supports some sort of swell pushing towards Hawaii and the U.S. West Coast. The exact details, though, are very much undefined at this point in time. Also, we want to take a quick look down south. Hard to believe it's Christmas and we're looking down south. There's New Zealand, Australia, Ross Ice Shelf starting to break up as summer sets in, but not to be denied. On Tuesday evening, a gale started developing under New Zealand, with seas building to 42 feet on Wednesday morning. continuing through the morning and then fading from 39 feet in the evening, but all pushing well off to the northeast. The point being, swell, not a huge swell, but small southern hemi swell, is in the water, pushing north towards Tahiti, and more so for Southern California because they've been locked out of a bit of the true energy coming from the north because the swell angles have all been pretty steep, and that really poses a challenge for swells getting in through the Channel Islands. But Southern hemi swell for exposed for good exposed southwest breaks in Southern California is in the water, steaming north, expected to be arriving later in the week. After that, though, the South Pacific is asleep and forecast to stay that way. A quick look at winds for California and Hawaii. On Sunday, light wind pattern, high pressure trying to push into the northern portion of the state. Yes, some wind, 10 knots down the central California coast. Trades for Hawaii, 15 knots, pretty standard fare, maybe a little bit stronger. We get into Monday, still light winds relatively speaking, trades die for Hawaii, but notice there's a front trying to push through, high pressure building behind that as we get into Tuesday. The north wind machine starts up for California, and that'll pretty much blow things out. Trades light for the Hawaiian Islands with low pressure building here to the north. That's just really killing high pressure north of the islands. So anyway, Tuesday night, north winds, but as we get into Wednesday, the front from this storm pretty much starts cutting this high apart, pushing it inland. Notice 1040 millibar high pushing into the Great Basin. But winds 10 knots or so along the California coast. Trades very light for Hawaii. As we get into Thursday, literally no wind or light south winds building over central California, southeast winds into northern California. Very light trades for Hawaii. Friday, front. A very weak front pushes into at least North California. You can see it. Look at the northeast winds, though, for the Hawaiian Islands. High pressure moving in. That'll pretty much blow things out for any of the north exposed breaks. So we get into Friday. The front pushes through into Saturday. A light northwest wind pattern. Notice the building low off the coast relative to California. Strong high pressure 1030 millibar high driving 25 knot east-northeast winds over the Hawaiian Islands. And as we get into Sunday, south wind event for California, probably rain, and looks like pretty much a mess. Trades return strong, but at least out of the east for the Hawaiian Islands as we get into Sunday. Quick look at precipitation for California. There we are, high and dry as of this Sunday. We're going to go out and look for the next week. Just looking a little dab of showers for Cape Mendocino as we get into Monday night. That quickly fades out. But we know as we get further in the week, and here we go, we're at moving into Friday. The front shows up. Weather expected. Rain down to nearly Point Conception by late evening. A little bit of light snow for the Sierra building overnight. Good solid snow for all the Sierra as we get into Saturday. Rain clearing out for California. And then we get into Sunday. And where are we? We're almost there. More rain, more snow for Sunday. So this is a little bit new on the chart. But a good dose of precipitation. California needs it. I think we're down at 20 or 25% of normal for this time of year. So every drop counts. Let's go take a look at snowfall. So, as expected, this is the Squaw Valley snow forecast dashboard. Nothing until we get into Christmas. That's the 25th. And then total accumulations of somewhere in the area of maybe 16 inches, something like that. Notice the snow level here. The freezing line is where the white it starts. This is the top of Squaw. This is the bottom of Squaw. So pretty high snow levels until you get to Christmas, and then temperatures plummet, indicating a change. And these yellow lines are the snow, where snowfall's happening. Use this chart to get the estimated totals, but it gives you kind of a rough idea at least. The point being, beautiful weather up to Christmas, but after Christmas, a little bit wetter pattern, certainly much cooler in the mountains and probably on the coast as well. So take that into consideration when you're making your plans. Quick look at Kirkwood, we'll say 21, 22 inches total. from between the Christmas event and the one right after that. See the blue lines there? That's the actual the snowfall. This is the complete accumulation over that period. Same temperature profile. You see it. Temperatures plummeting as we get into Christmas. And wind, yeah, pretty good wind event there right around Christmas, 60 knot gusts, and maybe much more as we get later in the 10-day period. And even South Central California, Mammoth, getting in the act with a 22-inch accumulation possible. Same deal. They're a lot higher, though. See, top elevation 11,000 feet, their base elevation at 8,000 feet. So by Christmas Eve, they're all in the freezing zone and stay that way for the foreseeable future. Winds, not as bad there. Stronger wind event up north. All right, time for the long-term outlook. What's going on with the Madden-Julian Oscillation and La Nina, or the El Nino Southern Oscillation, as it's collectively called? As usual, we like to start looking at the Madden-Julian Oscillation. It's a periodic weather oscillation that travels around the planet on the equator, traveling from west to east. And specifically, when it's over the Pacific, there are two phases of it, the active and the inactive phase. We're very interested in the active phase because when the active phase moves over the Pacific, just like it does anywhere on the planet, it's like an area of low pressure. It creates cloudiness, it creates wind and rain, but what that also does is it reverses the trade winds, or can reverse the trade winds, and imparts energy to the jet stream aloft, which feeds the storm track, which produces surf, and as the MJO moves south of California, produces rain. All right, so we're looking, this is the Pacific, the data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. This is the West Pacific here. This is the East Pacific here. That's the equator there. The dateline, 180, is right there. That's New Guinea over there. So not a lot of land mass in this picture. We're looking at the arrows only. The colors are water temperatures. We see strong, the bigger the arrow, the stronger the winds. Winds strong out of the east-southeast over the East Pacific, strong out of the east over the Central Pacific, and strong out of the east over the West Pacific, what we call the Kelvin wave generation area, because when the active phase of the MJO is over the West Pacific, that's when it does its magic in terms of adding energy to the jet stream. And this is where it can also produce a thing called a Kelvin wave. Notice water temperatures are very warm here. When the active phase moves over this area, it can reverse these arrows, reverse the wind direction, take this warm water and start pushing it to the east, not on the surface, but under the surface of the ocean. And eventually, that warm water might take 2 or 3 months, but it sort of makes like a pulse that pushes across. It'll erupt off of Ecuador, and if you get successive active phases of the MJO and successive Kelvin waves, those balls of warm water that travel east, it can start warming water temperatures here, and that's how you kick off El Nino. All right, it's anomalies though. This is actual winds, 5-day average wind speeds. It's actual, the anomalies, differences from normal for this time of year. And yes, we see winds are pretty much nuking out of the east in the East Pacific, but look at the arrows here. There's none. That means that's kind of normal. As we get to the Central Pacific, though, you see the arrows start building from the east, so these winds are stronger than normal. And then when you get into the Kelvin wave generation area, solid arrows from the east. So strong east anomalies, stronger than normal for this time of year. That would be an indication of not the active phase of the MJO, but the inactive phase. And then you scratch your head and go, wait a minute. The Pacific is forecast to boom. There's all the jet stream is roaring, and yet it looks like we have the inactive phase of the MJO or La Nina. And you're absolutely right in that assumption. And sometimes all this stuff doesn't correlate at all, and that's kind of the point. We talk about La Nina. We talk about the strength of La Nina, how it's going to be a bad year, and yet sometimes things don't work out the way statistically they should, and this appears to be one of those years, at least for right now. We're kind of eking out almost what feels like, at least this point in time, to be a semi-normal year. Now, clearly, the start to the season was horrendous, but for the couple of week window we're in right now, things are looking okay. The point being, make the most of it. We are in La Nina. It's a pretty strong La Nina. We'll get more into this, the detail, but you get the general idea. All right, let's move on. Next up, wind anomaly forecast, all right, for the next week and also what's been going on for the past month, all right? The blues are east anomalies. That's the inactive phase of the MJO. The reds are west anomalies, winds blowing from the west. That would be from Japan towards us. That's what we want. The reds are west anomalies. But, okay, let's orient ourselves with the chart here. There we go. The date line, 180, runs right up the middle of the chart. This is the whole planet on one chart, right? So the Kelvin wave generation area, the far west Pacific, starts right about here. You can literally see a line where the blue starts, and it goes to 170 west right about here. California is about 120, Hawaii is at 150, Ecuador is over here at 80 west. There's literally a seam in the picture, you can see it. So the Pacific goes from here to here, but the only part we're really interested in is here to here. And you can see it's been nothing but blue for a month, and we have a hole here, and you notice this hole sort of corresponds. Yeah, it's blue still, but not deep purple. And this hole corresponds to, well, all the storms that we've been having. That started pretty much right around in early December and is forecast to continue to about Christmas. And then notice east anomalies are supposed to really start picking up. All the west anomalies, the active phase of the MJO, the stuff that we're really interested in, is all locked in the Indian Ocean. And that's all this pattern is driven by La Nina. When you see east anomalies strong over the Kelvin wave generation area for extended periods of time, not just for like 30 days, but for a month or two or more, clearly a sign of La Nina, and we are in La Nina. All right, let's keep going. More MJO data now. More MJO forecasts, specifically outgoing long-wave radiation, cloud cover. Where it's cloudy is where the active phase of the MJO is. The blues are negative anomalies, meaning less sunlight reflectivity off the ocean surface, meaning more clouds, meaning, theoretically, the active phase of the MJO. And what are we looking at here? Well, there's the equator right there. South America, Central America, Hawaii. There's Ecuador, Australia. West Pacific, the Kelvin wave generation area from 135 east to 170 west. Dateline's right there, right? 180. So a box in your mind right around here. And we see the active phase in it per the statistic model, expecting to hang, but slowly get weaker over the next 2 weeks. That's a good thing. The dynamic model, not so. This is the GEFS model, the GFS model, the standard U.S. long, we call it a medium range forecast. Goes out 10 days is what we use it. Sometimes even only a week. But anyway, so the dynamic model, not quite so optimistic, saying active phase in control, but weakening with the maybe some flavor of a weak inactive phase, maybe setting up a week from now. Making a little bit deeper dive, this is using those same two models, the statistic model here, the dynamic model here, phase diagrams. What are we looking at? Well, this circle, imagine this to be the North Pole. There we go, like that. And you're looking down on the North Pole. You're looking down on the top of our planet, and the equator's out around the edges here, right? And the MJO moves from west to east, from the Indian Ocean, over the Maritime Continent, over the West Pacific, East Pacific, under the United States, across North Africa, back to the Indian Ocean. The MJO just goes round and round and round. Wherever the active phase is, let's say it's here, the inactive phase is on the opposite side of the planet. So the active phase of the MJO is where the heavy dot is, so almost trying to make its way into the West Pacific. And this is where it's been. You see November 12th, 13th, 14th, blah, 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 and then December starts here. Okay, you see December right there? Okay, this is where the active phase is right now. So trying to get into the West Pacific, the closer the dot is to this circle, the weaker it is. So if the dot was way out here, it'd be very strong. So a very weak active phase. And this, per the statistic model, 3 different member runs, all saying getting very weak, almost collapsing to nothing as it moves into the West Pacific. The dynamic model says the active phase, here's the track here, it does it in the green, says it's actually supposed to retrograde and fall back into the Indian Ocean 2 weeks from now. So neither one suggests a very positive outlook, though the statistic model is more positive in that at least the active phase is going to be supposed to be over the West Pacific. The upper level model is still dead. It's been down since December 6th, so we're moving right on to the CFS model, the one month CFS model, right? Whole planet on one chart. Again, Kelvin wave generation area, West Pacific starts right about there, goes right up the chart, and continues to right about there. This is past performance up here. This is the forecast. All right, so here we are today. The area we're interested in right here. Nothing but east anomalies. Forecast building strong from, these are 1 week, so what's that, maybe December 26th through January 2nd. Moderating some and then maybe building as we get east anomalies building as we get into January. Not looking good. This is, I guess, some sort of active phase of the MJO, which is already over. No, here's the inactive phase, the dotted black contours, the inactive phase. So just basically a nothing pattern going on. But the purple, you see it up here. See, MJO is the solid black line. The low pass filter, the purple right there, is 1, 2, 3, and it's dotted. So this indicates high pressure in control, or a high pressure bias in control of the Kelvin wave generation area, and not just weekly, but 1, 2, 3 contour lines. Again, that is classic La Nina kind of setup. And the low pressure bias, which is the solid contour here, is in the Indian Ocean. Again, another classic La Nina type pattern. So none of this is unexpected, but all this really kind of says is whatever we're getting storm-wise, none of this supports it. So it's all a gift, so better take it for all that it's worth. And then finally, the 3-month CFS model. Same deal, whole planet on one chart, date line right there. Kelvin wave generation area starts there and goes to about there. The forecast is up top, though. Past performance is down here. What you can see is the steady buildup of easterly anomalies. The blues are easterly anomalies in the Kelvin wave generation area. And looking forward from now into about Valentine's Day in February, even stronger building easterly anomalies forecasts. And then some sort of weak westerly anomaly, wind anomaly pattern starts setting up later in February into March. Let's overlay the MJO, see what that tells us. Okay, so here we are today. Inactive phase is the dotted contour here, and it's moving out of the Kelvin wave generation area. A very weak active phase is moving in and forecast to hold till January 21st. But in terms of westerly anomalies, yes, it builds some westerly anomalies in the far West Pacific into about January 5th, and then it all starts collapsing. No substantial support for storm development is indicated. And then the inactive phase comes in as we get, we'll say, mid-January into early February, and it only helps feed easterly anomalies, doing nothing for storm production. Then supposedly, as we get into February, a strong active phase sets up and kind of almost looks to be trying to kick La Nina out of the picture. We don't believe that. This model has just a horrendous tendency about a month and a half to 2 months out to always favor these strong active phases of the MJO, and this one here was supposed to look like that, but you see it's down to almost nothing now. So we're not going to jump on the hype machine with this either, say this is probably grossly overdone. All right, let's overlay the low pass filter here, dotted contour. So again, this also kind of overhypes it a little bit, but for right now, just looking at what's happening right now, this dotted contour, high pressure bias in control of the Kelvin wave generation area. There's the date line again, with 1, 2, 3 contours, supposedly building to 4, supposedly building to 5 as we get into February. And with the low pressure bias, the thing that we wish was over the Pacific, building to we'll say 2 solid contours in the Indian Ocean in February. So according to this would be the peak of La Nina right in this period. But we have some other data that suggests, well, maybe that's already happened. Let's get into that. All right, so no more MJO talk. Now we're going to be talking about El Nino, La Nina. We start with subsurface ocean temperatures. This is the East Pacific here. This is the West Pacific here. These X lines here are the anchors on the TAO buoy array. The X's are actual sensors on those anchor lines. That data is transmitted via satellite from the buoys to a central processing facility where a model is applied to fill in the gaps, and you get an idea what the subsurface ocean temperatures look like. When you're in El Nino, you have warm water in the East Pacific. This is East Pacific here. When you have La Nina, you have massive upwelling and cold water in the East Pacific. All right, so right now, the 29-degree isotherm, that's 29 degrees Celsius, which is pretty warm water, is in the far West Pacific. Yeah, it was, I think, like 160 at the eastern edge of it was at 160 east last week. It's made a little progress. We want to see this moving off to the east, but we're not expecting to see it. It's made it to 164 east. The 28-degree isotherm is at 175 east. I think that's about where it was last week. The 24-degree isotherm here was around 140. It's made a little foray to the east to about 128 west, something like that. And it generally, it's been hanging around 140. So what's going on here? Well, we have strong easterly trades. You saw it on the previous charts. Winds are just blowing, driven by high pressure both over the North and South Pacific. And what that does is causes upwelling, takes the warm water, pushes it off to the west, and then you get cold water upwelling in the east. So this is actual temperatures, 5-day average. Now let's look at differences from normal for this time of year, and that clearly paints the picture here. You see, here's your warm water in the West Pacific, 2 degrees above normal at depth, down 150 meters. That's what really matters. Making it no further than, well, where are we here? That's 160. So if that's 160, that's about 165 west. So all east of here is below normal, 2 degrees below normal, 1 degree below normal. There is this little patch of warming right here that started to show up that's kind of interesting. So we will see. Okay, but generally you get the sense. Colder than normal waters filling the entire East Pacific to the date line and beyond, driven by strong easterly anomalies and La Nina. Here's the same data using a different model. It actually shows the warming making it to about 150 west. You don't want to go down below maybe 200 meters. The real, where Kelvin waves do their thing is somewhere between 100 and 150 meters. If you had westerly anomalies here, this warm water would break off and start pushing up into here, into the East Pacific. But you see all this cold water here, driven by easterly anomalies. It's like a brick wall and just holding this warm water back. So what's happening is, over time, you have this cold water regime, but warm water, I mean, there's still warmth on the equator, right? And especially over in the Indian Ocean. And that water starts bleeding into the Pacific, and it starts building and building. It's like a water balloon. At some point, the dam is going to break, and it's all just going to go whoosh and swash over. How do you like the sound effects there? Swash over into the East Pacific, okay? And that would kick off El Nino. And how that would happen, a lot of it would be a weakening of the trade winds. The trade winds are like a brick wall holding this warm water at bay. Now, we don't expect the transition from La Nina to El Nino to occur anytime soon, but that sort of sets the stage. It might not be for another year, but again, latent heat energy is what drives the atmosphere, and latent heat energy also gets stored in the oceans, and we see it building here. Another quick confirmation of the water temperature pattern. Okay, what are we looking at? This is kind of a hard chart to read. That is Peru and Central America there. There's the Galapagos. There is Central America, Mexico. There's the Hawaiian Islands right there. There's the date line right there. That's the equator. Ecuador is there. All right, now you look at this, you go, well, there's the same blue pattern, there's the same reds, but this is not water temperatures, it's height of the ocean. Where you have, the theory behind all this is where you have cold water, the ocean contracts. And when it contracts, especially cold water at depth, 150 meters down, you get a little divot on the ocean surface. Where you have warm water expands, it creates a bump on the ocean surface. So you take the JSON-3 satellite, which we use to monitor ocean wave heights, you strip out all the waves, strip out the tides, strip out the wind waves, and just, is the ocean surface, how does it compare to a normal sphere? The normal spherical contour of what the ocean's supposed to be in this part of the Pacific. And what we see is, well, wait, it's 5 centimeters below normal, 10 centimeters below normal over this whole region here. And it's 20 centimeters or more above normal over here. And you also notice the negative anomalies are pushing in like a dagger into the warm anomalies here, suggesting trades are blowing, causing the upwelling, causing the negative anomalies, just like what we've seen in all the other pictures. So all this is saying is, yeah, this pretty much confirms what we saw with actual sensors. The other part here, too, is the negative anomalies here, they were at minus 15, almost pushing minus 20 at one point, and now they're down to minus 10. And they're down to minus 5 and little pockets of minus 10 along Chile and Peru, which suggests that the cold waters at depth aren't quite as cold as they were, let's say, a month ago. If you sit here and follow this daily like I do, and monthly, and then sort of build a mental picture and know where things are going, the trend seems to be that things are weakening a bit. So let's go look on the ocean surface. What is going on? Well, clearly, okay, the blues are below normal temperatures for this time of year, reds and yellows above normal. This is the same picture we've been looking at for weeks now. Chile, Peru there, cold water off of Chile and Peru. There is the Galapagos. They extend the whole way along the equator to the dateline, filling the tropical Pacific. Standard classic La Nina kind of picture. But also notice a little bit of warming in pockets along the coast of Chile and Peru. Also, if you remember, all this area was just packed with very deep, much colder anomalies back in October and November. That's all vanished. There's your coldest temperatures now in the Nino 3.4 region, and my guess is they're all pushing off to the west and will dissipate at some point. And we have a much weaker, though it's broad in coverage, a much weaker cool water signature than what we've had weeks and months past. Keep that in your mind. Sea surface temperature trend for the past 7 days also confirms that the yellows, warming trend off of Chile and Peru, and even little pockets of warming showing up along the equator. Yes, there are still pockets of cooling, but the warming, at least for the moment, almost seems to have the upper hand, and this is the second time we've seen sort of a pulse of warming in the past 2 weeks or so. So this is somewhat encouraging. We're thinking that La Nina might be past its peak. Typically it peaks in the early December time frame, but maybe it's peaked even earlier than that. And then again, the backed off view, you can see clearly this is not cold waters, but it's cool anomalies, water temperatures compared to normal for this time of year, and you see it's much cooler in this area. And why does that matter? Well, cooler temperatures hinder evaporation. Evaporation creates lift up and pushes energy up into the atmosphere. If you don't have that going on, then you end up with high pressure, like here and here, circulating that way, clockwise, counterclockwise. And what that does, so if you got a clockwise circulation of high pressure here, that creates east anomalies. If you have a clockwise circulation of counterclockwise circulation of high pressure here, which it does in the southern hemisphere, you get east anomalies, stronger than normal trades, and if that persists for a long period of time, you get this massive upwelling signature, which is what we have, and that is La Nina. All right, so all we're saying is, yeah, La Nina is still in effect, but it doesn't look as strong as it's been in the past. We forgot to do this chart when we were doing the subsurface. This is upper ocean heat anomalies when we were looking at the subsurface analysis. So we'll do it real quick now because it's germane to the conversation we want to have here. So this is the West Pacific here. This is the East Pacific here. This is ocean surface not ocean surface, subsurface temperatures down 300 meters. You can see back in, and April is there. That's when the cold water anomaly pattern started developing. Things warmed up a little bit in July, and then we sunk into a very deep hole between August, September, and October. In late October, Halloween, this was the peak cooling in the East Pacific, and then you can see since then things have generally been warming subsurface. You also notice we went from no heat in the West Pacific to a building heat signature in the West Pacific, also suggesting that maybe we are reaching the peak of this La Nina event. Sea surface temperature trend. This is in the Nino 1.2 region. That's officially like along Ecuador, the Galapagos, that area in the far East Pacific. You see we've been on a steady upward trend. Just lately, we've fallen down. We're at minus 1.035 degrees today, but we were at almost up to only half a degree below normal. Now, to be clear, the official La Nina threshold is half a degree below normal for 5 consecutive months, roughly speaking. So we've been in La Nina range this entire time, never have busted even above the minimum threshold. But this isn't the official El Nino monitoring region. This is out from 120 west, so a point south of California on the equator, out to nearly the dateline, 170 west. Temperature today, minus 1.018 degrees right there, a degree below normal. The trend, you see we fell into that hole in October. We kind of raised up. We're trying to work our way out of it. We're not there yet. We're still pretty much stable, what they would call a mid-grade La Nina. If you're below 1.5 degrees, which we were forecast to be, we were supposed to be down into the 2-degree range, that would have been a very strong La Nina. This seems more realistic given that typically La Nina appears after a El Nino type event. We've had a very weak 2-year El Nino-ish like event, so it's not surprising that we go into a La Nina. But a strong La Nina, that would have been kind of unexpected. This is probably even on the strong end of what would have, just eyeballing it, would have been expected. All right, one more bit of data. So we talked subsurface temperatures. Well, we talked the MJO thing. We talked subsurface temperatures. We talked ocean surface temperatures. Now we're going to talk the atmosphere above the ocean. The Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When you have higher pressure over Darwin and lower pressure over Tahiti, the index goes negative, and that means there's that's basically like looking at the low pressure bias. That means that you have low pressure over the Pacific, and that is a sign of at least the active phase of the MJO, if not El Nino. If pressure is higher over Tahiti, the index goes positive, and that means you have high pressure in the Pacific, just like the high pressure bias that we were talking about earlier over the dateline. Okay, and then, of course, so today's value is positive 10.02. Draw your eye down the past couple of days when we were at positive in the 30 range, quite high. Just scanning the whole way down here, nary, 2 negative readings, but nary, excluding those, nary a negative reading for the past month. 30-day average takes some of the noise out of this, plus 12.80. When you get in the 12 to 14 range here and it holds, you're in La Nina territory. You can see we've been pretty solid and going upwards. We're at 6.36, and we've gone up in the past month to 12. 90-day average, 9.49. It's been down in the mid-7s, but still working its way up. This will continue to go up. I mean, all this says is we're in La Nina. It's pretty obvious. The atmosphere believes we're in La Nina. The ocean believes we're in La Nina. The point being, the ocean and the atmosphere are coupled now. They're both in the same place, and they're both saying, yeah, we believe high pressure is in control, and this is the way we're going to be for a while until something goes and shakes the tree and knocks everything out of balance again. And what that will be is that, remember we saw that building heat signature in the far west Pacific? That will be the thing that will burst the bubble at some point. Not anytime soon, but it'll burst the bubble and get us out of this La Nina pattern. Here's the 30-day Southern Oscillation Index graphed out. We're not going to get into the details, but since, we'll say, July 2019, you see the steady rise to where we are today, all indicating a building La Nina pattern. When you're above zero, your positive range, that's La Nina. When you're below, you got to be below -5 or above +5, but -5, you're in El Nino territory. So clearly, we are not anywhere near an El Nino territory. We are going in the opposite direction, but at some point, we're going to reach a peak. We think we might be there, and then the bubble bursts. And finally, the official sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region. And here we go. So, in the past, January 2020, April, you see, we were in like an El Nino-ish type temperature regime, 0.7 degrees above normal. We started crashing in April, July, October. We got down to minus 1.25 degrees in late October. And notice we've kind of trended upward. This is actual data. We're at 1 degree above normal as we get into the end of December. This is the middle of the month here. Temperature is supposed to effectively hold into, let's say, mid-January. And then according to the model, we start moving upward, almost approaching normal, maybe minus 0.15 degrees below normal as we get into summer. So this is encouraging. And the other thing is, we never got down. This model at one point said we were supposed to be, by January 15th, we were supposed to be minus 2.5 degrees below normal. And see where we actually are and where the trend is now. So this is getting us to believe that perhaps we have reached the bottom of the hole and maybe a turnaround is coming for the future. So the good news is, hey, yeah, we're in La Nina, but there is surf. There is swell in the water today. There is southern hemiswell coming for Southern California in December. Who'd have thought? And there is a series of storms queued up on the models. The jet stream is looking good. The expectation is there is a fairly decent run of surf coming for the next couple of weeks. But based on the MJO type models, it looks like we're going to go into some more easterly winds once we get deeper into January. So make the most of what's coming and enjoy it. Consider it a gift because we are clearly in a La Nina pattern. And that isn't going to change like in the next week or two or month or two or even for the next 6 months. Okay? So make the most of the little windows that we have. We got a good window coming. I'm going to go do it. Anyway, all right. So that said, the good news is swell is in the water. The forecasts are looking good. There's even some snow forecast. I mean, we have a 35-inch base or a 39-inch base in the Sierra right now. Not good, but hey, you can go ski. The resorts are open. There's no hotels, there's no restaurants, but you can drive up for the day, go ski, go board, have some fun, come back, and then go surf the next day. That's the joy of living in California. All right, so a longer term, we think we have reached the peak of La Nina. The models sort of hint at maybe some sort of resurgence of strong easterly anomalies as we get into February, but I'm not sure that I really believe it anymore. I mean, typically La Nina peaks out right around early December. And we're past there, and temperatures are rising. The trade's still pretty strong, so it's still an undecided jury at this point. But we are cautiously optimistic that maybe we're past the point. Now, that doesn't mean that we're moving into La Nina and all's going to be great, because there's a lot of cold water on the Pacific. It's going to take months for that to be unlodged. Let's say even If it does just what the model says, by July, maybe we'll be into a normal water temperature pattern. But the jet stream still will take 3 to 5 months after that to, sort of respond in kind. So we're talking the November-ish time frame of this year to when you sort of start getting a sense of normality, which already is starting to cut pretty good into next winter's pattern. And we're not even into this winter yet. So no major turnaround expected. Typically, the switch between El Nino and La Nina is, if it's a strong switch, it would be in the February time frame. So if we were to venture a guess, we would say maybe February a year from now, there would be a switch. So that's speculation. For right now, the good news is there's swell forecast. Make the most of it and be safe. Have a great Christmas time with your family and friends. We are going to try to do the same. We're going to do the same thing. We're going to try to maybe take some time off. So not sure whether we're going to do a video next week or not, or it might show up at some sort of odd time. But either way, enjoy. It's been a interesting year stuck inside, but at least we have surf. If you enjoyed the video, give us a thumbs up. Where are we? There we are. Give us a thumbs up. We'd really appreciate it. If you haven't subscribed, please subscribe. Click the subscribe button. You'll get automatic notifications when we post new videos. If not, go to stormsurf.com. Up at the top there, we post a link to the weekly video. All the data that you've seen in the video is available on stormsurf.com. Just dig around through the site. You'll find it there. And other than that, be safe. Have a great holiday. Have a great new year. And we'll keep doing it, hopefully, next week. All right. Thanks for watching.